Hello, welcome to the stream. So, um, I have not done anything yesterday evening, so still same state as in the end of the last live stream. So basically, I had some thought of improving the model which is currently failing. So this is referenced as the 156K model, which has some deficiencies in the HyperMesh RBE connection modeling state. I will quickly show that model also again, and then present to you my idea of how to fix that maybe. It's a pretty easy idea, I would say, and it depends if it's computationally efficient. If that's the case, then I think we could implement it that way. If not, then I would say we refrain from doing so and just leave it as it is for right now. That means that we would have the, the problem with some sort of RBE modeling. So that would be on the user to fix that. In the output, I think it would be visible. And also, clearly, you can see if it works or if it does not work. But maybe we can also do some print statements and stuff like that. To just have it a little bit more, yeah, precise, right? So let me quickly open the HyperMesh model. This was the mid model. Basically, the idea is the following. So maybe let me quickly show what the problem was. So basically, I think this is a HyperMesh instance, a HyperView instance. We would like to have a HyperMesh instance. Let me see that I can really show that to you. So that should be... I think I never saved it as a HyperMesh model. Oh, that's a shame. Well, it doesn't matter. We can build it from scratch again, so that's not a problem because it just involved 2 commands, something like that. So basically you see what I did here, and this one was failing. This one is the original model. This one works. So with that I have no problem. And to have something like this, you can see, maybe, yeah, you can barely see, but maybe you can see it a little bit better like this. That here, the connections, here it's already fixed. So I think I didn't overwrite. Okay, so let's forget about the right side. Let's do the left model and just adapt it. So what I did here was I split the elements here around here to just simulate something, which made our model fail. And I will just do that once more. So there would be 3D and then edit elements and then split. Now I would like to split solid elements, so I can select that. I right click here to select the circle selection mode, then select a bunch of elements and then say split. So basically that's what's happening. And you see all those connections here, they are just 2 nodes apart. So there's always a node in between which is not connected, right? So if I have the node selection tool here, that's connected to the RBE, that would be a slave node. This is not connected. This is not disconnected again. So what our tool right now does is it does the following. It builds a graph based on all the elements, more or less, or all the nodes and how the nodes are connected, right? And then it builds for each element, for each rigid element, it goes and builds a subgraph. A subgraph is just a copy and paste thing. And if that's more of interest to you, how this really works, you could check out the last stream, I think. That would be, or for sure the streams yesterday, because I think all the implementation was being done there. I may do a video of it with a condensed version of it. But if you see something in Paint with modeling, then you can understand, I think, better the subgraph. But basically, it's just all the nodes which are connected to this RBE, and then the question is, how can I form the connected groups, right? This should be one group, and the lower one should be one group as well. But it's failing here because the thing is that I have no connection from one slave to any other slave node in the subgraph. There's no connection, right? So this is basically the problem. And now the idea is the following. Why do we even work with the subgraph? Well, for one, it's a lot faster. Right, so if you have a subgraph and you would query something in the subgraph, it would be a lot faster. We also saw that yesterday because there was some problem which I thought I could solve with the complete graph. Well, and I did that, and then the timing went to eternity, so very slow, and that was not feasible. All right, so that's that. But still, again, I'm going back, I'm revisiting the idea of using the complete graph once. And the idea is the following. Maybe let's sketch that on Paint as well, that we have a clear understanding what's going to happen here. All right, so the complete subgraph consists of all the nodes, right? So we have all the nodes and all their connections to each other. We have those connections too, because we did a lazy job of implementing it, but I will not draw them, they are not needed. Then we have something like an MPC, which I always colored with red, which connects to some of those nodes, right? Maybe like this. Here you can see the problem in the subgraph, which would be this, because those are all just the elements which are there. There is no connection in this modeled state. There is no connection here between those two. That means it will not find a connected group which consists of all those three nodes, but it will find one group sitting here and the other one sitting here. This is basically the problem right now. Now, we have something like this yellow thing, right? And I will just take the edge color now as a method of differentiating between two parts. So let's say we have another part here, and I will now use blue connections between those to just make it clear what it is. And let's just say we have some connections to this part as well. All right. Now, in an ideal world, what we would look like, what we would look for is one group being those nodes here. So everybody who's connected, yeah, something like this, and the other one here, right? Now, the idea is that I have this method of querying a graph into connected groups. And if I do that on the whole graph, I would get one group, second group. So it doesn't really bother much with the MPC, but it's just having the whole parts in groups. And then I could do the following. For each RBE 2 element, so in this case I'm looking at this one, just make the intersection of the slave nodes and the individual groups. If I do that with the top one, I would get exactly what I was looking for. If I do that with the bottom one, I get exactly what I was looking for. So it has at most this many groups as it has groups in the whole graph. And that makes total sense, because just think of it, what it actually does. It just says, all right, this model has two connected groups. And the RBE2 could have one or two of those connected groups in the slave nodes. And basically, to make this this grouping, what I just draw, it's just a simple intersection. What are the common nodes of my slave nodes of the RBE element and the parts, so the connected groups? So that's basically the idea. And the only doubt I have is whether the calculation of connected groups in the complete graph takes too much time. Or maybe also the intersection between the slave nodes and the connected groups. But just from my stomach feeling, I would say we have a pretty fair shot of having good, mid to good computational efficiency. So let's try that. Basically, the first thing I would like to do then is check the GitHub and check if we have a branch for that, or even I think we still have this branch. Yeah, we still have this branch, test a graph-based approach to better the performance of the slave node group detection. So basically, this would still work as a branch, right? So I think I can also stay on this branch and just continue implementing it. We can see that here in the Visual Studio Code on the lower end, there's the branch name. And so basically this now is a working version, but it will not work for something like this. All right, and this I was frustrated yesterday and just gave up on it and said, all right, then it's on the user to have something which is better defined than this. Because what our current algorithm makes in such a situation, it just has as many connected groups as nodes. So you would have 180 different groups, and the summation is just not possible at all. All right. So basically, that's not good. And I think we have a fair shot of fixing that. So basically, let's start simple. Let's start with getting a model which we can test against. So this model we have right now is the model I think we could test it against. And for this to be possible, I think we should just run it. Maybe we should do a renumbering, because that got us last time with the MPC forces file, as I could not really see what the things are. So let's just renumber everything. Let's renumber the elements. Oh, wrong tool. So let's renumber those elements from 1 to whatever. So this would be... Oh, and actually it's not the elements we're interested in. Oh, you know what? We just renumber everything and hope for the best. Okay. Yeah. Now let's see if that was any good. What is a typical ID here? 42,000. 44,000, 41,000, so that makes somewhat sense. Let's check the other edge as well. Oh, 27. Okay, let's check the lower side. It's not good. It's not good at all. Okay. Sorry, we have to do that a little bit more precisely. So again, the renumber thing. So what I'm interested in is the nodes, the node IDs. Okay. So basically, let's just do the top part and renumber that from 1 to whatever. So 23k nodes was that. Yeah. Okay, and then let's renumber the lower nodes. And let's just give it 30K as a starting point. Let's also not forget the master node. Okay, so I think we can then differentiate between those two. Now, let's export and analyze this with the analyze function here. And how should we call that? That would be 3D mid broken, I would say. Right, so we can really see that this should fail in our code right now. Okay, I run that. You cannot see that because it's on the other monitor, but just have to trust me that it's being run. Time to fetch some tea. Maybe speaking also about timing, I plan to do a stream today until at most 1.5 hours from now on, because sleep is important too. And yeah, I have neglected that a little bit. By the way, if there are any questions or so regarding Hypermesh, regarding Python or so, just put them into the comments. I'm more than happy to talk about something different. It's just my fun evening exercise here, what I'm doing. All right, so we are here now, and there should be now a data model mid broken, which is fairly new. There's no properties. Yeah, I'm not trusting that. Let me check that in a Windows Explorer. That I'm sure I have the correct model. Yeah, mid broken. So we would need FAM, MPC forces, and SPC forces. And I copy that into the input folder. And there are some files in there. So broken. Input, copy. Yes. Okay, now there should be something in here. And we can test the model and see that it will fail. So you see here, 3D mid broken. This is the one I just copied. To use this, we then have to go to the main model class, which is in the SPC forces tool, MPC tools. Now, here's just, I have to change this one. This is the model name. So 3D mid broken. I think that's it. So if I do a task run here, this should then run and make this detection algorithm sum up the forces. Yeah, and takes about maybe 20 seconds or so. So not too much. Even faster. No, pretty fast. Okay, so what we now have is in the data output, there is a mid broken. And there's the summary. And you can see now it has very much of those components. Yeah, basically you see here slave nodes is one for every connected group here, which we can see. All those groups belong to one RBE element, because there's just one RBE element. But you can see here there's 188 slave nodes, and you can see here the part ID, and the part ID will count up to 180, right? That makes sense, because no node is connected to not one node. So yeah, it's just 188 parts. So this gives us nothing. Basically, that's completely useless. All right, so we can change that. Now, how do we do that? So basically what I would like to change is the method of creating the graph, maybe. Okay, let's think through. It's definitely here. And then it's definitely in the rigid elements. And it's definitely here. Yeah? Basically, I don't want to throw away this for now. So I will just make a copy of it. And the duplicate code is not good for right now. Okay, let's rename that. Sum forces by connected parts. And yeah, from whole graph. Oh, okay. No. I can make a different way of it. Because there is already functionality in this method. Where is it? Here. There's useGraph, there's a boolean, and I know from a design point of view that's not a good way to do this, but I will just create another boolean. Use complete graph. And I will just make that true for now, so I don't have to do anything else right now. And see if it works. So if use complete graph, else. All right. Huh. Basically, I think that maybe works. Let's see. Self part ID to node IDs is self get part ID to node ID IDs graph. So graph is just information that it will be using the graph. And then what it wants as an input is a list of nodes. So if I just do a list element graph nodes, that would be all nodes. That would be the complete graph. So basically this method then builds this graph, which is the complete graph. As you know, output of an image. And then the connected component is a list of connected components. And here's the transformation into node IDs. That makes all sense. So basically this could be all there is to do. But now let's see. What do I do with this? So for part ID, node IDs in this thing, forces is being selected, blah blah blah. The thing is, where do I do the slave node the intersection? I think I'm not doing this. I'm not doing this. So this is in this case, this is wrong. So let's say this is part ID to node IDs whole graph or complete. Whole graph. I know it's the element, the variable names are not good. But yeah, just think about it. What this is doing, it's getting. Let's do that differently. To connected node IDs. Node IDs. Yeah. And now self.part ID to node IDs equals, and now we do a list comprehension. Oh, that's a bit difficult. Now let's do that with a for loop. But I'm already into 2 levels into if, so we should not do more than one for loop. And even that is ugly. Maybe also make a method out of it. All right, self part ID, blah 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 blah. Let's make a method. So basically what I'm now doing is I'm making the intersection between the slave nodes and the connected groups for every group. I hope this makes sense. If not, please just chat. I'm happy to explain that one more time, or maybe I'm also wrong here, but just think about this. So the blue nodes and the edges and the yellow nodes and the yellow edges, those are two different groups, which I would expect to being returned at exactly this location. So there should be a 1 and then a link to all the nodes in yellow, and then a 2 and all the nodes in blue. All right. And then for every of those groups, so for the one group and for the second group, I have to do an intersection with the slave nodes, dramatically reducing the size of the lists. Okay, so this is what I'm planning to do here. Yeah, so let's just do something like a method. That seems right. It's exactly this location where I'm normally messing up the most. Yes, there is a problem. Here, there should be something part ID to node IDs. So for part ID node IDs in this thing, blah blah blah, you're building that intersection thing up and then you're returning it. Yeah, makes sense. So I have to give this variable into the method we just now created. Let's make a comment here. Get connected nodes for each part from all nodes. Then get intersection with the slave nodes. All right, so that would be that. Let's do a task lint because I'm sure that there's something which we might have been overlooking. By the way, if anybody of you has Spotify, there's always a Spotify jam link down there. I'm not sure if that's something which would make sense. But if you would like to listen to the same song I'm listening to, then you could do that. Alright, so there's nothing in the linter. That's a good thing. That's a good thing. And now let's do the task run and see, first of all, if it works. Then let's look at the timings. I'm not sure how much time it takes to build that graph. Everything else should be pretty straightforward. Now it takes longer, right? And I'm also not sure if this thing is not being done multiple times. No, right? No, should not be done multiple times. Yeah, basically, what I think we are not doing again is we are back at the running times from the initial version of growing from one node to the other. Yeah, that takes too much. Wait a minute. Is it running even? Shouldn't there be a yellow mark? Or am I It's not running, right? Ah, yes, it's running. Sorry, I'm wasn't confusing. The task run option does look differently to the run option with F5. Yeah, that takes too long. Yeah, okay. Maybe it was a good idea, but the running time does make it almost impossible. Could that be that I have still a problem in the code? Let's cancel it. And let's see again. Basically, what I'm interested in is if it's the getting connected groups, or if is it something differently, what takes too much time. So let's make a point here and just see. Okay, maybe that makes no sense at all, right? This thing. Oh, but wait a minute. Wait a minute. I think that's not necessary at all to do the subgraph here. Let's do that differently. So it wants the slave nodes list here. Why? Because it wants to do the subgraph. But what if I would do... I would want to have a graph. Right? Because then I could just do this thing. Right? So this could be then gone out of the window, and then here it would be a graph. Like this. Okay. So now I changed this method completely to have a graph, and what is it? Annex.graph. Let's get this correct. Okay, now I changed this method completely. This is being now used here. So let's do the following. Graph is element.graph.copy. So basically here, if I'm now here, I would do the graph. Yeah, no copy. So here I would use the graph, and here I would use, that's also the graph method. Here I would use graph.subgraph with slave nodes. So that should be it. Now I'm still not 100% sure if that made it better, but we will see about this. So I have a point maybe here, and then we will run it again and see how the timing is. What is it? What takes so much time? Is it the intersection calculation? Is it because we just now made something which was necessary before, we made that obsolete and we removed it. So that's nothing, that's nothing, that's nothing, that's nothing, hopefully. Huh, it's not nothing. maybe we should not visualize it. That takes a lot of time. Yeah, if you just think about it having maybe 10 or 20 or 40,000 nodes, you would want to make sure it's necessary to visualize it. And this position, whatever pos means, nx spring layout, that could mean that for every edge there's a string, a spring, and then there is something like a calculation of how it would change. So yeah, okay, so okay, let's just remove that. I swear that I would not remove it, but yeah, in this case, let's maybe just comment it out. I know the linter will complain again, but I don't care right now. I'm just interested in this method. If this method takes too much time, or was it the visualization all along? It could be. It could be very well be that it was the visualization. From my stomach feeling, I would say it should not take longer than the growing method which we had earlier. So I would say 20 seconds or so, but well, it has now more elements. So we would have to take that into account. So here comes the trick. Huh. Doesn't take very long. So how long is it? Because that should be pretty long list. Yeah, 23k. Yes, that makes perfect sense. All right, I'm feeling lucky. I'm just pressing run. Oh. Cannot unpark non-iterable int object. Yeah, do we have to do something like items here? I think so. Yeah, you know what? I'm removing the breakpoints because I think the problem is now not really there anymore. Well, the problem we had earlier. So it was the visualization, right? Huh. All right. Now, if the output is correct, I'm taking this as being the next evolution of it. So that will be here. No. Okay. All right, we have to do a little bit more. Something here is not really working. Because that should have two connected components, right? We will see about this. So, this is an empty dictionary. Now for part node IDs in whatever. Yeah, so this makes sense, right? So, and the self.nodes is the slave nodes. Those are the 188 nodes. Yes. So let's go over here, and it should happen twice, and now it should return. Now part ID to node IDs. Oh. Interesting. Did the set thing not work? There are no... Ah! I think I know the problem. What did I add here? Is it the node IDs or the nodes? So basically connected components is a list of connected components, and then it does the node ID. All right, okay. So I think here the problem is we have to do something like a slave node IDs. Something like this. And then this should be then compared with the intersection of slave node IDs. Then it would not be an empty list. Well, wait a minute. There could be something wrong. ECB, what you working on? Yeah, so I'm working on MPC forces tool, which does the following. It calculates the forces which is transferred over MPC connection. And it does that by summing up different parts. So one part is down here, one part is up here, and you have to detect those two parts. And this is what I'm working on. So I'm working on a graph-based group detection algorithm for this. And I'm very much looking forward to having a little bit of an increased performance to yesterday, and also to have some models working now which did not work before. So this is basically it. But if there's any questions, I'm more than happy to also shift my attention to something different. By the way, we have around 50 minutes or so. Yeah, sure, no problems. If there's anything more you would be interested in, if seeing something what the model is doing, I could do that as well. So basically, why this is failing is it has no connection between slave nodes. So it's a little bit an awkward RBE connection, but I would like to have the tool being able to do this. So basically, what I just thought of is that we now here lose a little bit the part IDs because they don't make any much sense at all. But on the other hand, maybe it's not that bad. For now, I would say I will ignore that. All right, so let's try again, and hopefully now it works. If it works now, I can also explain what the output is, and maybe that makes a little bit more sense then. I mean, the timings are great. The most time it takes is reading in the FEM file. So that is really good. Okay, so we have now the summary. Yes, it works. Oh my god, it works. Nice. Nice. Okay, should we do a little bit of an explanation of the thing here? So what we have here is the output of the whole program. You can see something like an input FEM file. You can see an input MPC forces file. So all the forces for each node in here is listed in the MPC forces file. You have a date and something like a header. And then you have, for each rigid element, you have some data. Yeah, so rigid element with that ID. You have a master node ID, you have the location coordinates, and then you have slave nodes, 188 slave nodes. And those are being separated into groups now. The algorithm detected two groups, 1 and 2, 94 nodes each, and the sum forces of one side is 500 newtons in X, and the sum of forces on the other side is minus 500. This is pretty much exactly that what we applied. We applied 500 newtons here. So those 500 newtons are being seen here at the connection. And the other 500 newtons in the other direction are seen here. And basically then also here in the SPC forces. We did not go into the SPC forces at all, although the tool still is called SPC forces tools. Well, maybe we will do that shortly, but just look at the MPC forces file. That may also give a little bit of that information why this is important to do that even. You see the MPC forces file, it just has a grid ID and the force. You don't have any idea what RBE this belongs to and what side. So algorithm balances the slaves. Yes, it balances it, but basically it's not really balancing it. That means it's not doing a force balance or something like that. It detects groups. So that means the first idea was something like start with one node of the slave nodes and then just grow all the nodes until you reach the end. So you would end up having all the yellow nodes in one collector, then make the intersection of the slave nodes and this group. Yeah, so all of those. And then you would have, if you do the intersection, you would really have all those nodes. Right? Can you imagine? All the nodes here. You do that a second time because you now just have assigned the upper ones to a group, and you would do that the same thing here, and then you would have the two groups. But this was slow. So the next iteration was to use graphs. Graphs meaning you have vertices and edges, vertices being the nodes, and edges is the connection between nodes. And then you're building up, and I could maybe talk about the latest iteration right now, so skipping the mid iteration where we had not the total graph. So by using this graph, you can then make a subgraph. But basically, is that even the case now anymore? I don't think so. But just think of it like this. We are not growing with neighbor relationships in order to do our grouping, but we just have one giant graph of the complete model. Subject of math is graph theory. Graph theory. This is a huge subject, and I'm not as skilled as I should be in this. So from a mathematical standpoint, yeah. So there are much better people around who could teach graph theory, and it's basically maybe it's not the best implementation of doing something like that, but it's definitely better than the neighbor detection thing. Because if you just think about the neighbor detection thing, that's maybe handy for a different kind of problem, but here you had data structure implicitly modeled that, or explicitly modeled that this element has a list of neighbors, which included all the elements surrounding it. And then you could do something like grow one layer. This is also implemented, by the way, in Hypermesh. You could do select by adjacent. Yeah. And this is what our initial algorithm did. It did this multiple times. Adjacent. Control J. Yeah, I can do that. Okay, so just think of it. The first algorithm did this. Select any node here, get the element, and then just do this. Bam, 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 growing, growing, growing. Ignore the lower elements. So for the model here, the RBE element counts as an element 2. For my model, it did not. So you growing, 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 growing until you're there. But this takes time. So the graph has the information of connected groups in it, so that there is better ways or easier ways to get connected groups. So basically that's what I'm doing. That means you have the whole model, have that model represented as a graph, and then take this model or this graph and get the connected groups. So basically that's the yellow part and the blue part. And then for each RBE element, we just have one. You make the intersection of the slave node with each group, and then you get the upper nodes and the lower nodes. That's a grouping. And you see, this is how I then was able to sum up the parts, and then you have something like the output. And for this project, it's very simple. This is a trivial project, but well, basically, no, it's more or less a simple project, I would say, but it has grown from the beginning. So with all the roads which ended with the sign of we have to turn back, yeah, so it took a while to do it, maybe a couple of hours, yeah, a couple of days even. Yeah, but basically what the purpose of something like this is. Just think of something like a flange or so. Let me just see if I can give you a short example of it. Maybe on grab CID. Yeah, just think of something like this. You have some flange or some design like this, right? With many connections. Yeah, for example, here you have maybe 8 connections or so. You would have to do this summation multiple times manually, and this would be quite tedious to do. So you do this if you have modeled the screws or the connections as rigid connections, right? And for that thing, you could just think of maybe I should do something like this. Yeah, that would be maybe a really good idea to just take such a model, mesh it, hold it in place on one side and then pull on the forces on the other side, and then we can see what our tool will get us. Yeah. Yeah, if you have any questions or so which I could help you with, just shoot them out. So there's nothing preventing you from taking advantage of me being here and having some free time and using that for mechanical engineering questions. So if you have questions, just go ahead. And if I can, I will answer them to the best of my ability. Yeah, but for future content, maybe I think really that would be a great thing. What is it? I have it as IPT. I don't know what IPT format is. But let's maybe look at something which I have as a step file or so. Is there a step file? STL would work too, but not too good. Step images, yeah. Well, I would like to have something not too complicated. Maybe something like this. Yeah, that seems not bad. Okay, let's just download this. So wait a second, I will download it. Yeah, let's do some hypermesh preprocessing. If I have work experience in this field, yeah. I have some, yeah. On learning engineering from a CS background. Well, you know, I've gone the other way. I have started with an engineering degree, bachelor's master's, and did also my PhD in this. But in the PhD thesis, I had a lot of connections to computer science. Basically, I was just nonstop programming for 5 years. And I have seen the other way around. Honestly, I think the yeah. Or that's a good question. If I had a CS background and wanted to start engineering from scratch, how would you start? Do you have a favorite textbook or book? You know, the problem is engineering is a huge field. It's really huge. And that what we are covering here, I would say, is the mechanical engineering calculation side of things, so structural calculation. So this is well, if you would break down engineering, and I would get a lot of hate for this if it has, because there's many different opinions on that subject. But if you just look at engineering from a very meta perspective, I would say you had maybe two distinct groups. So you have design and you have the stress calculation. So the one is how should it look? How should functions be integrated more like a visual type of guy? Somebody who can very much work with shapes and likes to yeah draw, also 3D CAD drawing, something like this. So that's the design world. Then you have the calculation world. So stress calculation is dealing with something like we are doing here, but not the coding stuff, but a little bit of it. But more or less this world. The question here to answer is, will it hold? Will it break? How much tension, how much compression do we have? How much stress is there in a certain area? What's with fatigue? What's with, I don't know, some frequencies? Eigenmodes, stuff like that. It's just structural understanding, structural mechanics. This is the main field. And then you have all these different branches which have more or less both of them, but none of them in common. So maybe something like a process engineering, how to manufacture something, how to then electrical engineering, right? You controller design. You have so many things. All right, if you would like to go into the stress engineering field, with having a computer science background helps tremendously, because you think you have this understanding of how algorithms work. And basically, if you just you could do, well, Just think of it. There are many software providers of engineering solutions, right? So you could go into something like this. But if you want to go away from coding, which I could totally not understand because I love coding, but if you would want to step away of it, then maybe as a mid step, I would still recommend you to work at a software company which does software for engineering. It's like Altair. All right, if you love that too, then maybe something like Altair or some different software engineering software provider is very good, because there you're dealing with the stress problems, but you're doing that basically what I'm doing here right now. So you're working on a problem which has some relation to stress engineering or structural mechanics, and you're working to solve this problem by using your background as a computer science guy, right? So if you do that, you have the best of both worlds. Yeah. I would recommend to just put yourself out there. I know the computer science market is a little bit tough right now, or just the IT market, because yeah, what you hear from layoffs and stuff like that. But engineering wise, I can just speak from Germany, but what I see, engineering, nobody wants to do engineering anymore. I cannot understand that, but we have dropping student rates like crazy since years, and that's a shame. That's a shame. But there will come the time where we would need a lot of engineers, and even, I mean, the intersection between computer science and engineering is, in my opinion, one of the most wanted topics you could look for, because there you are really at the edge of problem solving. So those qualities you have there is pretty good. So if you go into both worlds, like the computational side of things and to the stress side of things, if you understand that, there's a lot of mathematics involved too. But and yeah, I mean, I cannot stop talking about this, but you could also go into the AI world, so machine learning, stuff like that. Um, I mean, the possibilities are endless. But I would suggest that you putting yourself out there and just try to collect software companies for engineering problems. Like Altair, for example, would be one. You could definitely also look for Ansys, or maybe smaller companies too. So you just have to find someone who provides a software solution in the engineering world, and then look if they are looking for IT guys. That's your entry. Yeah, machine learning. Yeah, yeah. The problem is machine learning is such a buzzword in nowadays. Yeah, so everybody talks about AI, but I don't know. What I liked more is I like more of thinking about algorithms and seeing how to solve problems. And if you talk nowadays about AI, it's almost 90% the same word as LLMs. And I'm not sure if it's really worth it to pursue something like the LLM developments, because there are very few companies who really have an edge. So there would be Meta, Google, X, and for sure OpenAI. Those are the companies who have the resources, who doing real advancements in the AI branch, right? All other companies, I'm not sure. I would think that the hype will not last forever, and will cool down very shortly, in my opinion. I'm not 100% sure on that one, but yeah, the AI bubble is, yeah. Optimizing transformers is that algorithm problem space for sure, and what I'm interested in. Transformers. Yeah, so transformers is a big topic, right? Actually, I don't know too much about transformers in general, but I would say, well, where could you could do that? Well, the problem is, as I said, the topic is huge. Yeah, so AI startups, yeah, you will see us very much of that, but I think a lot of them will die and die pretty more sooner than later. I just recently saw something about Microsoft putting AI in their documents, and yeah, something like Excel, right? If you just think of a chat window where you could chat with a ChatGPT like chatbot, which then can execute Python code, which then transforms your data you have in Excel and just gives you some output, or something which also can do a PowerPoint presentation for you. If that is really sincere, then I think a lot of small AI startups with good ideas and also good software will die. Just because Slack cannot compete with Teams. You just have the market share of distributing your software to every client who has Office, and everybody has Office. So everybody already has the possibility to do, I don't know, PowerPoints with AI. So what reason is there to buy another program from a AI startup, which can do the same, maybe worse? Because yeah, Microsoft has resources the small AI startups don't have. I'm not sure. So it's a tough topic and tough to estimate where this will go. But yeah. So if I were you, I would just try to get something like an internship as a software company providing engineering solutions. That would be my guess. All right. Enough chit chat. Let's now do something with the new model. Maybe we will keep something here because why not? So for example, the property and stuff like that is still. No. If I delete the components, it's all gone. No, p-solids, I have that. Yeah. You have a class? All right, take care. Thanks for stopping by. Seeing you around. Have a great day. Yeah, so I downloaded the step file and I will just, yeah, let's just start from scratch. So don't save. Let's just import the step file and see what we have here. Okay. Yeah, somehow I think I've seen that before. Okay, the first thing you should do at something like this is defeaturing. So let's think about what should we keep and what shouldn't we keep. I think the screws we will not need because, yeah, the screws. Why is it showing that? No, that's too much. All right, so let's just delete all this. All right, so the first thing is defeaturing. So you see that this is the model and you see all these round sections and stuff like that. You really don't have to have that. So basically what you have here is with, what is it again? Topology and then defeature. And then you can go to the fillets and then you can do find. And if it does not find anything here, you can check here the menu and see the parameters. Let's put something really small and press find again. Okay, yeah, that worked. So let's remove those. And those are not really fillets, but chamfers. There is, I think, an option to do this also here. But let's just see if it works if I do it like this, just to select it. Yeah, that does not work. Why? Because you see it. Yeah, and the reason for this is that I selected only part of it. Maybe it works now. Yes. But let's see if I have something like that. Isn't there something like so? This is just this. Why? Because I can if I remember correctly, the chamfers was also selectable but I think I don't see it right here. So if I do something real big, see if I find something more. No. Okay, so we have to do it manually. At least that seems for me the case. Maybe, yeah, well, all is all. Yeah, rounds and fillets, okay. We have something with batch. Oh, we can try batch. Auto cleanup. Did it change? No, it did not change anything here. But it changed some suppression here. Yeah, doesn't matter. Okay, so basically also we don't care too much. I'm just doing that here for fun. So the featuring, let's select this, not this. Can see that that's all done here. Oh, not auto cleanup. Sorry, I should have chosen fillets. Okay, once more. This. By the way, there's a pretty cool way of doing this in Ansys. You can just double click anywhere here and it will automatically find all connected. I wish they would have that too here. All right, again, another thing. And again. And again. No, that was not the one. No. This one. And this one. And this one. And another one. By the way, if this view is not the best for you to work on this one, you can already, you can do this and go to component. Then you see it like this. If that works better for you, then you can do it also like this. All right, so this should be good. We have something more here. So from the inside, we can do that too with the feature. So select both of them and the other side too. Oh, it's more than one. Yeah, then let's go back one step and just hide one of those components. And then we see, oh, we have more of components we maybe don't need. Right, so. Okay, and now here. Yeah. We can go on with the defeaturing, so we could change that. Maybe change also this. Yeah, that we don't have the hole at all. Yeah. That seems about right. And then we have that, and that. Okay. You could even go one step further and doing all this. Yeah. And basically, now we have done so much that maybe we should do something differently. So this is the part which we changed. Right? And we could just throw away the other part and make something like a duplicate here. So copy, paste. Right? The parts is strange. Yeah, let's not consider ourselves too much with the part. So, and now we want to move the part because we duplicated it, right? So we can do component and move. And now there is this simple trick of moving the coordinate system. And you can see that when you are close to the origin, it will snap to it. And then there's one, there's one thing with shift. Yeah, you can reposition the coordinate system. Because what this allows you then to do is just flip it over around this axis. Right? Like so. And now we should be... No, we are not good. We're not good. We still have something to do. We have to fix the rotation. Yeah, let's see about that. So move this part. The axis is correct. And now let's just see if we can dial it in. Like so. Should be good. If you would like to do that more precisely, there's definitely an option. You can measure the angles between two nodes and stuff like that, and then just rotate it like this. Okay, maybe that's not really right, to be honest. It doesn't look right. Let's just do... No matter how it is rotated, it doesn't look like. Yeah, well, this looks right, yeah? So you have the opposite sides. All right, now let's do the meshing. So basically this now should be meshable also with hex mesh, I think. But before doing that, we have to split the geometry. And this is being done with topology and then split. I'm using planes for it. Target has to be a solid. What? What? Those are not solids? You're joking. Those are not solids. Okay, we have to create the solids first. So that should be 3D solids. And then bounding. Oh, it's not closed. What? It's not closed. We have something was messed up. Okay, let's see. This is something which looks fishy. So topology, there should be something like stitch. If that's everything, we should be fine. So 3D solids bounding. Does it work now? No. No targets found within specified as stitching distance. Something is not right here. Oh yeah, the beauty of geometry editing. Oh man. So let's see. Stitch, still something not quite working. Is that now everything? Here again. Let's turn off the mode that it is. Like that, yeah. So we have just green lines, right? So that's something good to see. Now I would suppose that it would now work with the 3D solids option with the bounding box. Yes, now it works. Okay, great. And great. Okay, now we have the solids. Okay, now we can also split the solids. We do that with the topology and the split option. Then with plane, we take this nuts, we take this solid and split it at this location. Right, this seems right. Split. Let's also change the color scheme to mappable. Oh, it's still not mappable. I would. Ah, okay, because of that one. So this solid. Huh? Why is that not mappable? You're kidding, right? Okay, screw the mappable. We will do we will do the TED mesh. Okay, so now let's do the homework here. I will do a quick visit on my GitHub page because I have some scripts there which make it easier to have just the basic things like properties and components like that. So what we would like to do is a 3D analysis thing. So I will just copy the 3D analysis script. Maybe I should have done that before importing the geometry. But anyway, so view TCL console, and then we'll just copy that in. Now it will generate another component, which I'm not really interested in, but those two parts, I would like to assign them the design property. Doesn't make any sense to have a non-design property, so let's delete them. And I think I can now do the meshing. So 3D TED. Let's just think of a reasonable element size. So 3 would be reasonable for my purposes here, I think. Let's see how it works. And also, reminder to myself, save the model. Because I'm always afraid of segmentation errors, and so should you be. Segmentation errors are nasty because they just end your program without you having the possibility to do something about it. So let's do that right now. File, save as, hypermesh model. And then let's do, wait a second, I have to search that. So that's HyperWorks tools, data, and then I will just call that flange. Okay, that's that. And let's now mesh the other part as well. I wonder why it took so long to mesh. That should not be that many elements. Yeah, but yeah, let's see. By the way, drinking some delicious tea right now. Called China Wulu Mountain Bio. It's a green tea. Also called the fog tea. It's on the region of the mountain Yantu. Yeah, pretty awesome. Has been gifted to me by a friend. Yeah. All right. Now why did it turn now purple? Property, okay, yeah. Yeah. All right, so we have that. Meshing is done. Then let's create some simple geometry load case. So let's create a load collector. Isn't there? There should be load collectors here. Normally. I did not in the script. I'm 100% sure there should be a load collector. Why isn't? I will just copy that code, that section of the code again, and yeah, I knew I had that. Okay, so we have load collectors, 2 of them, the SPCs. Let's do the SPCs at first. Let's just do something very stupid. Let's just hold it in place on one end. Yeah, I mean, you know, this is, you can see it. This is for transmission of a moment. But it's not what I'm interested in right now. So let's do something more simple. All right, so what should it be? We should do analysis constraints, then we will just hold Would it be enough to have... No, it would not. So let's hold one node in place. Completely in place. All constrained. And then let's do all the other nodes. Can I press Alt? No, that does not work. But we can select a, not nodes. Here. By face. Yes, and then select that. And then let's just select DOF1, yeah, the X direction. I want to hold it in place into the X direction. All others can be left. All right, so this is done. And then let's do the loads. Make current. Here. And let's do something like a RBE3, although I know that I might set myself up for failure here, because this is not really an RBE element connecting parts, but that has just one part. And by the way, also notice that I have the same property for both of them, but still there should be two different groups here. So it should work, but this RBE3 here could be that I'm messing that up. But yeah, no pain, no gain. So where is this? Not here. I think it's in the model. Yeah, Rigids. Let's do not rigid wall. Oh no. And you have to be so careful. It creates that automatically. Doesn't ask. All right, RBE freeze. Let's do something. Let's calculate the dependent node. Let's select those nodes. By a face. This one, yes. Okay, so we have that. And while we're at it, let's create the rigid as well. Oh, that would be interesting. By face will not work here, I think. Yeah, more or less it works. Okay, another round. By the way, great tune right now. It's called Be Someone, Lost Frequencies Remix by Joachim Pastor. So, if you want to have a great tune, this one is a good one. All right. Okay, now we have that. Next one is the one down here. Okay, and now we can create the force with analyze force, and let's use our 500 newtons again. So magnitude would be 500, and the direction would be 100, or minus 100. Cannot see it. Let's just make that, yeah, here it is. Let's change the color, something a little bit more visible. Okay, so we have that. So you see, I have constrained it on one side, being held in place. And on the other side, I have a uniquely distributed force over the RBE3 connected slave nodes. And then we have 3 rigid elements, and we would like to get the forces transferred over for each one of them. And if everything works, then they should take roughly the same load. But it will not be the case anymore if we change the direction of it from being a pure X direction to something which has an angle. Because then you have something like tension here and compression here and stuff like that. And so this will be interesting. By the way, take into account we don't have contacts right now. That's maybe not such a good thing. But for the tension case, it doesn't matter. It doesn't matter. Yeah, so I will change that maybe later. But for today, because I think I have just 5 minutes more left and then I should go to bed. So it has to work now. If it doesn't, yeah, bad luck tomorrow more. So let me simply analyze this in flange.fem and run it. Hopefully I did not make a mistake in setting it up. Could be. So properties were set correctly, I think. Then load step should be good. What else could go wrong? Yeah, what else could go wrong? I did not set up the MPC forces to being outputted, and we have programming errors during element quality check. Ooh. Yeah, that's not good. But where could it be that you have such a bad element? Let's check that simply quickly. Well, the easiest way to checking quality is with this element quality index. So QI range. Cannot see something right now, right? So change the thing here to being transparent. Huh? So from first sight, I cannot really see. Ah, sorry. Should have gone to 3D. Ah, here. Oh yeah, that doesn't look very nice. That doesn't look very nice. And the problem is if you have something like this, you have to do the things again. Normally, because I thought the geometry shouldn't look that bad. I would not thought that it would have such a bad problem here, but yeah. Yeah, okay. Yeah, I think I will have to do a little bit more. I'll just delete the elements. But you see, you have to do the rigids again. You have to do the RB3 again, the forces again, all that good stuff. So let's change the visibility again to automatic. Why doesn't it delete it? Okay. All right, back to the TED mesh. I cannot see something. Yeah, okay. I can see something which we should have done is a washer split. Is there something easy what we could do in topology? And let's search for it. Washer. No, there's nothing here. But there should be something. So we could go the long way and just create the washer splits here. Yeah, I think we have to do that. So let's just go for a 10 millimeter. And let's go here too. Okay, we have that, and then we can do the the topology and then the split again. Then with lines, target should be solids. I would like to split all solids on this line, and this line. And the direction should be in Z direction. And to do that, I will just track those 2 points on the surfaces here. So the direction would be in X, extend rimmer, split. Yeah, seems to have worked. Now let's do the meshing again, and let's check that we have something as proximity and curvature refinement, and the growth rate should maybe not be 1.3 but 1.1. Minimum size factor should be maybe 0.4, not 0.1. Select the solids and mesh it. And then let's check the quality before we go any step further. It's always the same with something like this. You try to do something like a quick thing, and then, yeah. And then it turns out to be a little bit more demanding than what you expected, and then you're sitting there until midnight. But if you would, you just have to like it. There's no other way, I think. Let's see how this comes out. Definitely there will be more elements to this than the previous thing, but I think that would be also a good thing to test how good the code will scale. Okay, did that work? Let's check. I'm a little bit anxious of if it works. So let's check element quality 3D. See if we still have those nasty elements. Yeah, we still do. That's maybe the min size. Yeah, min size, but that collapse. I think this will fail us. All right. Why is it so bad? "370 elements have a problem." I'm not sure what this is doing, to be honest. Let's go back. Let's go back. I don't like that. It really didn't do that geometry refinement, did it? Okay, let's do that again. Let's do that again. And let's maybe try to select also the order of doing the meshing. So TED mesh create. So here, that should be it, right? TED collapse greater than 0.1, maybe greater than 0.3. Yeah. Something here, optimize quality, that's good. Yeah. All right, let's start with those components. Let's just do one. Let's see how this turns out. It's a little bit strange that it takes so long. So for here, I would say that should be pretty okay. So let's do the small things first. Maybe. It's a good thing to split those components again. Because I think the quality for this should be okay. The quality for this should be okay. I don't get why this takes so long. I mean, those are simple structures. If the program now stops, I'm going to bed. No joke. I can't get why this is doing so much work for those few elements. That seems a bit off. Maybe there's something wrong with the geometry here, after all. Not sure about this, but it now says optimizing tetra size. Why the hell does it take so long? Alright, now it has that. I mean, yeah. Now, what I thought would be maybe a good idea to just make a cut here. Right? Yeah, I'm not sure. I will do that. Let's split by plane. Target should be this. This. And we would cut it here. Split it. That should not affect any element. And let's do it on the other side as well. Oh, that doesn't seem right. Ooh, what is this? I think there is something wrong with that. I will split it now, but maybe it was also just something. Yeah. Whatever. Okay, now let's try to do the TED mesh. And do that for one solid. Let's go with a bigger size. That was quick, as expected. This now maybe has this problem. Could check the quality right now, right? Yeah, we still have them. God damn it, what is this? But wait a minute. These problems arise from the original from the washer elements. Okay, so we still have something here. Huh. Interesting. Maybe after all it would be a better idea to really do the hex mesh. I mean, if you just look at that, that's just awful. Okay, let's try that. Let's try to do a split of it and see how far we can get with that. Okay, shaded geometry. Then, because we don't really need those things here, let's defeature them away. Defeature. We would like to defeature this. That. What? Okay, now I think it's coming handy to do this selection because now you can see I can. Ah, what the? Ah, okay. I think I have to do a reverse. Okay, and I cannot do that. Okay, then I have to merge them back together. So I do boolean combine this, yes, this, yes. Okay, now it makes sense. I think it made sense earlier too, but I did not see that because the face here was not really to the feature. Okay, the feature fillets, and I would like to defeature those. Yes. That looks a little bit awkward. Maybe also that was the problem why it did not work. But I will try with that, and if it's not working now, I will just call it a day. Okay, we have that, and now we do the splitting and see the mappable. Normally I would say if I do a split here, it should be mappable. Okay, this one is mappable, but this isn't. Why? I don't know. But let's suppress. Let's suppress. Is that suppress? Yeah. Let's suppress. Why? Let's suppress this edge. Yeah, and this one too. So there's nothing in here. Okay, let's suppress this edge. Yeah, you see, something like this can also mess with the meshing. So let's split this one too. This is even more, I don't know. This really does not look good. But anyway, we also have this strange stitching behavior. Okay. But now I would say this is hex meshable, but this isn't. What? You're joking, right? Why is this not meshable? Is it because of this line? But this should be one solid, right? Okay, the only thing I can do is suppress this edge. This doesn't... Huh? Okay, wait a minute. Can I just merge that again? Because for the hex mesh, I don't think I would need that washer thing. So if I would merge this, and this. This is now not mappable anymore. Why? This thing should not be mappable. I mean, I did that. Maybe if I've suppressed those lines. If I suppress those lines, maybe I can have it then meshable. That doesn't make any sense. Why is that not meshable? Mappable. That's so strange. Maybe it's something with the surfaces. I'm not sure. I'm not sure about this one. I would say this should be mappable. Very strange. Somehow here it worked, here it didn't. I cannot think of why this is. So let's merge them all together. Ah. Ah, what the hell is this? Wait a second. Did I just combine those two? Oh, okay. So this for sure should be split here with 1, 0, 0. If it's now mappable again. Wait a second. So if I do split again with the lines option, can do all. Let's not do it. Ah, what the hell? So target all lines would be that. Not sure why this is not doing automatically. Yes. Still, it's not mappable. That doesn't make any sense, really. But I tried once more. I mean, just because I cannot believe that this is such a bad thing here. Huh? That didn't work. So maybe do it one by one. How can I unsuppress something? I mean, it's almost good, right? It's just those little things here. Yeah, okay, I'm not sure why this isn't working. I will just boolean merge them all together. So the easiest way is just combining all. Not surfaces. Why the hell is it surface? No. Huh? I'll just combine all now. Okay, now we have that. Now we can split it again in the middle. Okay, we have that, we have that. And I don't know why this is still strange. Let's maybe do an auto cleanup. Maybe this helps. No. Okay, so it doesn't help. I'm not sure why this... Ah, I think I know now. Alright, so split lines. I would like to do the target those two. And the line should be those two. And the direction again. Did it split it? So this was the only thing I could think of, which is maybe preventing that from being split a bit. Yeah, okay, I see. There is something wrong here. You see that here? That doesn't make any sense. So I think here was something bullshit happening. What the hell is this? But now, you see, somehow this solid here in the middle is still... Okay, somehow I think the splitting also did not work. So with lines, target would be those two, the lines would be those two, those three. And we have to give that stupid... Okay, the other one is working now. Is it now a solid? Okay, this is a solid, this is a solid. I cannot see why this is not splittable, mappable. Then this is a solid. This is a solid, should all be mappable, to be honest. So two things are not mappable right now. Yeah, you know what? I think I will have it call it a day. I will try once and just try to load it in again. And just see if I can get it mappable. The names are funny. So we can focus on one of those. Make now that the featuring. Can the find thing does not work. Why the hell doesn't it work? Oh yeah, okay, it works for this little thing here. And then we have to do something manually here. Then let's maybe do the whole thing in one go. Normally I would say, so somehow that didn't work. What the hell it does here, I don't know. Maybe because it's, yeah, it has something here. So let's do that first. Then this thing is really strange. Okay, that should be all. That looks good. Then let's maybe do all of this. That looks good too. All of this. That looks good too. And again. Looks good. We will now try this one more time. And wow, it's mappable. What did I do? Yeah, somehow you just have to start over. Somehow you have to just start over. So, part 1. And now we just copy and paste it. Move that to the center. Move maybe that one to this location. Because if I now do this... No, doesn't work. Okay. 180 degrees. That makes sense. And then something like... No. Something like this. So this aligns. Alright, so this is now far better. It's even mappable, although I did not do the defeaturing on the top here. What? Oh, it's not even possible to defeature those, huh? What? What? Ah, it fails. Okay, interesting. I mean, I have no problem to keep them, but normally I would say... Ah, what did it do here? What did it do here? You see, those are somehow connected now. Okay, now this worked, okay. Ooh. Okay. Okay. Still works. Now, the hex mesh should work now. Alright, I have to do the thing here again. And create the components and properties and stuff like that again. So there's no design component. Design property is set, and that should be also the design property. Now, non-design property should be gone. All right, now we can do the meshing again. So 3D hex, no, map. Let's just create a test mesh with 5. I mean, we should have more on this side. But to be honest, I don't want to go that deep into the meshing. Let's just do something like this. Check the element quality and be done with it. Oh, meshing failed. Interesting. Meshing failed. I mean, what I would like to do is make that split. So let's do that. 3D split. So target is solid. Let's use this solid, not lines, plane. So that split worked. Let's do it on the other side as well. Okay, that worked too. So I don't see why this should not work as a map. Meshing failed? Interesting, huh? Okay, one more split I can think of. That would be topology, split lines. Target would be the middle two solids. Lines would be those two lines. That did not work. So, let's see if it now has an idea. Let's do 2 millimeters. I don't see why this should fail. Let's try. Meshing failed. Come on. That's so stupid. Okay, let's do it one by one. Let's start with this one. So this works. Then let's do what was that? Okay, let's do this one. This should be fairly easy. Meshing failed. Meshing failed. So the problem we're having is those two. Ah, I see why. I see why. It's those stupid lines. I'm not sure what those lines should resemble, but they are really nasty. I mean, this line. Alright. Let's just try to mesh it once more. I think this might be the only problem we had. Let's go again with the 3. I think that worked, right? So let's just check colors. And let's save that model. Alright, now back to business. So we have the load collectors already set, but before I forget it again, let's also check that we have the MPC forces output. So output, we don't really need the SPC forces, but the MPC forces should be there. That's right, yeah. Format should be opti. Okay. Now that's that, and I would say then we can do the load step again. I'll order widgets first. Yeah, let's do the widgets. That should be not a problem. So widgets, calculate. Let's do faces. Okay, let's do the RBE3. All right, let's do the analysis. Let's do the load. Okay, it's there, right? Yeah. All right, let's do the constraints. One node is completely fixed, and the other nodes are fixed in one direction. Okay, that's that. So we have everything, right? Save the model and let's run the analysis. Somehow something feels off if I have forgotten something, but we'll see about that in a minute. Okay, so I press the run button and error missing property referenced by cquad. So basically this is a pretty common error if you have something like this. Did you see it? Here. There's some quad elements still here. That means I have to go to the view and then the mask browser, then to see the 2D elements only, then make an element selector and delete the elements. Then just having everything again displayed. By the way, I did not check the element quality, stupid mistake again, but I swear if we have a problem now with the element quality, I will just make the following. I will just suppress the element quality check. Yeah, I think that's okay, right? This hopefully will not fail. But if it's failing, then I will just deactivate the goddamn element quality check for now. All right, we have 800 megabytes of memory allocated for this run. The run is running and it's completed. Now let's see if it works. Now is the time. Okay, let me just quickly move the output files to the input directory. So that would be MPC forces and the FEM file. So I can now go to the flange. And here I can just quickly do this. Where's the mouse? Here. Okay, and here I just have to change the name here to flange. And run it. See if that works. And how long it takes. So basically what we would expect would be something like 500 divided by 3 per RBE element. Somehow that's maybe a printing problem. But it does that for every RBE element, so we have to maybe check. But not today, not today. Let's see if the output is correct. If the output is correct, then I will call it a day. Now, the flange summary. Seems good. Yeah, yeah. I mean, that's perfect. That's perfect. So this is the RBE3. By the way, I think I should do something like the information if it's an RBE2 or RBE3. That would be very helpful. But you have now 167 newtons per screw transferred with this load case. If I had a bending load case, that would be completely different. But then we also had to do something like contact surfaces and stuff like that, which we will be doing, but not today. So it has been a pleasure, guys, girls, everybody who's watching. Thank you for attending. If there's anything more I could do, some suggestions about how to move this project further and stuff like that, you're very welcome to comment that or write me an email. The only thing left for us to do is commit this thing, because I think this is pretty good what we have done today. So I'll just do a quick task linting. I think linting could have a problem, yes, because the matplotlib is an on-off thing. I will have that commented here. Although maybe the linter is complaining about that as well, because that's just being used if I have to do something with displaying the graph. Okay, so this works now, and it's now I wanted to commit that. Changed to graph from whole model. Broken model now works. Okay, I can commit that. Hopefully the pre-commit now will not flag anything. Should not, because we tested the linting and the testing, and that worked fine for both of them. And yeah, I will call it a day afterwards. So thank you all, everybody who has been here, and yeah, see you around later. Maybe tomorrow. I think I will be here tomorrow as well, and see how much further we can get that. I mean, we are now at a point where it really gets funny, because we can now really put this tool to use. Until now it was just getting some solution working, and now we can test it on bigger models. Yeah, and I think the running time was pretty good now. Alright, thanks guys, have a good one, and see you around.